Right. So let us move to the first problem of our finite state machine. Construct a DFA which accepts a set of all string of zeros and ones having at least 3 consecutive zeros. So you look at that diagram statement of problem. Construct a DFA which accepts set of all strings. So it is a zeros and ones. It accepts it. At the same time, it must have 3 consecutive zeros. At least 3 consecutive zeros. It may be have more than 3 zeros also, right? So that is a measure. I have to identify this is the measure critical point. You have to identify it. So then I have to take down the minimal string here. So first it is a minimal string is a 3 zeros should be there, right? So 3 0. Then followed by it can be 4 0. So for that you have to construct a diagram. I need to construct first diagram. First 0 is consummate. We'll go to the next state. Then second 0 is consummate. We'll go to the next state. Then third 0 is consummate. We'll go to the final state, that is double circle, right? So I will not give a label here. At the end you can give. Okay. So now 0. So 3 zeros consumed it. For that it is accepting it. You can see that other combination also. Still it is accept. Second string has taken here. So 1 0 0 0. It is accepted. So this is also valid string as per the problem statement. Look at that. So it has one. See, because already 0 is there. Start with 1. It could be start any number of ones at that beginning. Okay. Then I made that is a 1. Then it is a 3 zeros. Okay. So third string has taken starting 0 0 0 0. It can be end with any number of ones at the end, right? That is valid. It take one more 0. 4 zeros is come. Already 0 is there. 0 0 0. It can be one more 0 will come. Okay. It can end at any number of zeros at the end. Then 0 1 0 1. So 0 1 0 also valid because since it contains 3 consecutive, at least 3 consecutive zeros. Now 0 it is already there, right? So 1 is not there, right? How to do that? We'll go back to 1. It will go back to 1. Then 3 zeros. Then one more string has taken. It is 2 0. It take 2 zeros here. 0 0. Then you will have to go back to the first state. Then you achieve all the 3, right? Okay. So and so on. And so on. Clear it. I'll show you this. I'll label this Q0, Q1, Q2, Q3. Right, I taken some input here. I animated this. I have taken a lot of time to animate this. Look at this, how this animation is happening. We'll go to the start with the Q0. First it will go to the second state on input, first 0, reach to the Q1, and it will become 2 zeros now. From onwards it will reach again there is a input 0. On input there is a 1 transition. It will move to the Q2 and it become 1 0. Again there is a only one more 0 is there, that will go to the last state, that is a double circle. It landed, accepted it. This way it can be constructed DFA, right? So continue example. I have taken one more example on same in animation. I have taken second 0 1 0 0 0. So you look at this. The first 0 it may go to the second state. Then it will move on to the next state. Then 3 zeros as usual. Then it will move to the next state. Then it will move to the other state. Then accept it. So with this I think understand that animation as well as the construction way of construction of DFA or DFSM. And finally you need to write it. The M is equal to Q sigma delta Q0 F, where Q is Q0, Q1, Q2, Q3. Then what is the input as taken here? 0 and 1 as with respect to the transition diagram. So these are the Q0 is a starting state with respect to this diagram. Then final state is Q3. Then finally transition table. I have written the transition table. Okay, a transition table here it is a this starting state is indicated by arrow, that is